So the area of the curve that we have to find is, the equation is 1 plus 8 upon x square, right? So we know the formula is y dx. Whenever we are evaluating area with respect to x-axis, the formula is y dx, right? And we have to find the area between x equals 2 and x equals 4. So if we now substitute the value here, we obtain a equals 2 to 4, 1 plus 8 upon x square dx, that gives dx. I am just solving the integral here. So this we obtain as x, upper limit is 4, lower limit is 2, and here we have, this is minus of 1 by x. This we can write 4 minus 2, and this, what we are going to do is, we simply change the symbol, and since we have changed the symbol, so what we are going to do is, according to the formula, we also need to exchange the limit, right? So lower limit will now be the upper limit, and upper limit will now be now lower limit, okay, because we have changed the symbol. So this gives 2. This is just straightforward simplification now. 8 half minus 1 by 4. This gives 2 plus half minus 1 by 4 is 1 by 4 multiplied by 8, that gives 2 plus 2 equals 4. So the area with respect to x-axis of this curve is this one, right? A equals 4. Yeah. Now what next is given is, we have to evaluate the value of a, small a, given that I am writing this in a separate column, 2 to a of this curve equals half of a, which is 4 by 2 equals 2. Yeah, we have to find the value of a such that this is half of the total area. So this is pretty simple. We will again substitute the value here. 2 to a, this equals 2. This gives a minus 2 plus 8, 1 upon x squared dx equals 2. This gives a minus 2 plus 8, 1 by x, sorry, this will be 2 to a, and since the same strategy, lower limit will be upper limit and upper limit will be lower limit, because changing of the symbol, this equals to, I am just simplifying here, a minus 2 plus 8 half minus 1 by a, this gives 2. This equals a plus 8 half minus 1 by a equals 2 plus 2 equals 4. I just transfer this 2 from left hand side to right hand side. In the right hand side we have 2, and when we transfer this minus 2 to the right hand side, it becomes 2 plus 2 equals 4. Okay, if we now simplify this, a plus 8 by 2 4 minus 8 by a equals 4. So 4 and 4 will get cancelled out from both sides. Yes, Therefore, if we simplify this a minus 8 by a equals 0. This gives a square minus 8 equals 0. Yes, this gives a square equals 8. And we obtain a equals plus minus square root of 8. Okay. So, we have two different value of a. One is a can be square root of 8 or a can be minus of square root of 8. But we have the curve domain starting from 2. I mean, it starts from 2, right? The branch. See, in the question is given the part of the curve, right? So that branch of the curve. So our concern is that branch which is falling between 2 to 4, not beyond that. Yes. Since this is a negative symbol, yeah, minus of square root of 8, this will fall beyond of this 2 to 4. Yes. So we cannot accept this value. Okay, we will reject this value. So the only possibility therefore is a equals square root of 8, which simplified to 2 root 2. So what is the value of a? Value of a is 2 root 2. Yeah. If you have any doubts on this problem, I just simplify this. I just substitute the formula and simplify this. There is nothing so big deal here. But if you still have any issues, let me know. Yeah. A root x plus bx. We have this curve given, okay? And what else are given? It's given that x-axis and the line x equals 4. Let's say this is x equals 4, okay? Given that x-axis and this line x equals 4, and we have to find the area of the curve that falling inside this region. Yes, this is what it means. So what we have to do, since our our region of interest is this part, use some different color, orange color. Our region of interest is this part, right? We don't know whether the curve is in the positive side or in the negative side, which branch of the curve is on the upper x-axis, or which part of the curve is on the lower part of the x-axis. We don't know this, but all we know is that we have to find the area of this curve that falling inside this region x-axis and x equals 4. Okay, so we know that area x equals 0 to x equals 4 is given by, we will simply substitute the value here. What is y in this case? We have y is a square root of x plus bx dx. Substituting the value, we obtain a, simplifying, we have to simplify more. Only after that we can substitute the value. What is the formula for square root of x dx integral? It means x to the power of half, right? And if we integrate this, it will be half plus 1 by half plus 1. So this is x to the power 3 by 2 by 3 by 2 from 0 to 4 plus b, this is x square by 2 from 0 to 4. Yes, if we simplify this, this is 2 by 3 times 4 to the power 3 by 2. Yeah, b, then 4 square by 2, because lower limit is 0, so you don't bother about that. A times 2 times 3, 4 3 by 2 means square root of 4 power cube plus b 16 by 2 means 8. Okay, it is plain simplification now. A times 2 by 3 2 cube 8 plus 8b. If we simplify this, this is 16a by 3 plus 8b. Okay, so you obtain the area as 16a by 3 plus 8b. Yes. Now the area of the curve is given as 8 unit. So we can substitute the value here, that 8 equals 16a by 3 plus 8b. Okay, but we have two variables here. Let's say this is equation 1, but we have two variables here, right? A and b. And with two variables and one equation, it is not possible to evaluate both the variables. Yes, but one more condition is given here, and that is the curve passes through 1, 2. Yes, this means that y minus a root x plus bx at 1, 2 equals 0. Yes, substituting the value here, this gives 2 minus x equals 1, so this is a plus b equals 0. This gives 2 equals a plus b. Now we have two equations, two linear equations with two variables. Therefore, from here we can easily evaluate both the variables. Yes. So now it boils down to simplification. So what we are going to do is, if we multiply equation 2 with 8, 2 times 8 minus 1, this gives 16 minus 8 in the left hand side, and in the right hand side we have 8a plus 8b minus 16a by 3 minus 8b. This 8b will get cancelled out, and from here we obtain 24a. Let me write it down. From here we obtain 24 minus 16, that is 8a by 3. 8 from left hand side, and from here we obtain a equals 3. Yes. Now if we substitute this value here, we all know this, right? How to solve linear equations. So this gives 2 equals 3 plus b, and from we just substitute in 2. Okay, from 2. And this gives b equals 2 minus 3 equals minus 1. Okay, therefore the value of a and b is a equals 3, b equals minus 1. Therefore the curve is y equals, let me use different color, the curve is y equals 3 root x minus x. Value of a is 3, value of b is minus 1. We simply substitute the value here, and from here we obtain the curve. Okay, in this problem you have to find the area of this curve. So by seeing the equations of this curve, what you can guess? We can guess lots of things actually, you know. The first thing is, actually this is a very important problem for concept. The first thing is this curve. I mean, if you notice the function here in the right hand side, notice that this curve, I mean this function, let's say this is fx. Can you say anything about this function? This is an even function, means f of minus of x equals fx. Yeah, this type of function is called as even function. What is the significance of even function? This means that this curve is symmetric with respect to x-axis. Whatever it looks above x-axis also looks same below x-axis. Okay. On top of that, you can conclude the same thing about this curve with respect to y-axis. Okay. This curve is also symmetric with respect to y-axis. Actually, this curve looks something like this. Okay. Maybe the drawing is not that much good, but I think it is understandable. Because it is symmetric. So, we just have to adjust here so that it looks symmetric. Okay. And it is also symmetric with respect to y-axis. Therefore, see, this curve looks something like this actually. Okay. So it is symmetric with respect to y-axis, it is symmetric with respect to x-axis. So the way it looks in the left hand side, the way it will look in the right hand side, the way it looks in the upper x-axis, the way it looks similar as lower x-axis, lower part of the x-axis. So simply by noticing the equation carefully, you can conclude lots of things actually. You will get lots of, your concepts will be clear. So what you have to do is you have to find the area of this curve. But before evaluating the area, can you tell me one thing that have you ever noticed any other curve, something like this, which is also symmetric with respect to x-axis, with respect to y-axis? Yes, it is very common actually. There is a very common curve exist. It is circle of origin at O. The center is at origin. A circle whose center is at origin is also symmetric curve with respect to both x and y axis. Okay, the way it looks in the upper x axis, the way it looks similar to the lower x axis. Similarly, the way it looks in the left side of y axis looks similar to the right side of y axis. Okay, so whenever you have a symmetric curve, evaluating its area is very easy. How you evaluate the area of a circle? You simply evaluate the area of any one quadrant, yes, and then you multiply with 4. How you evaluate this area of a circle? You simply evaluate the area of this part of first quadrant. Let's say you have given a circle whose center is at origin of radius anything ABC. How you evaluate the area? You first integrate in the first quadrant and then you multiply by 4. Yes, 1 2 3 4. We will follow the same strategy here because it is symmetric with respect to x-axis, it is symmetric with respect to y-axis. So if we can evaluate the area of only one quadrant of the first quadrant, then we are done. Yeah, if you can evaluate this area, then we are done. Yes, it is pretty simple. So we are going to do the same thing actually here. Let's say this is A. So what we are going to do is we will evaluate the area from O to A. Okay, and then we will multiply with 4. Okay, very simple. So I am using some different color here. But in order to evaluate this O to A, we need the value of this point, right? It will be something like a comma 0. We know the coordinate of origin, this is 0, but we need to evaluate the point A, yes. But that is also very simple. For that, what we are going to do is we'll substitute y equals 0, yes, and this will gives x square a square minus x square equals 0, and from here we will obtain x equals 0 or x equals plus minus a. Since we are in the positive x-axis, therefore x cannot be negative a, x will be positive a. So this is a comma 0. This is, so a is in this case actually a comma 0. This is y dx, area of this region, area of the orange part, orange shaded region. Area of the orange shaded region is 0 to a, y dx. Now, what is y? Y is x by a square root of s square minus s square dx. Yes? Did you understand what I did here? See, we have given a square y square equals x square s square minus x square, right? This implies y square equals x square by s square minus x square, right? Now this means y equals plus minus x by a square root of s square minus x square. So y have two different values. One is x by a, I mean one is with positive symbol and another is with negative symbol, right? I mean one is this part and another is for this part. Since we are interested only on this part now, so, and we know that in the first quadrant y is positive, therefore y will be x by a square root of s square minus x square. We will not take the negative value, yes? And lower limit is 0, upper limit is a. So 1 by a 0 to a x square minus x square dx. And we know how to evaluate this integral. Also, there is a very standard formula to evaluate this integral, right? So we will simply substitute the value here, yes? You can either take a substitution approach or else you can directly evaluate this integral without any substitution. I will show you both actually. See, x square minus x square dx. If we put s square minus x square equals u square, then this gives minus 2x dx equals 2u du. This means x dx equals minus of u du. If we simply substitute the value here, we obtain u, and then for x dx we have minus of u du. This is u square du. This gives minus of u cube by 3. Yes? Now we will substitute the value of u here. U square equals s square minus x square. Therefore, this is basically s square minus x square 3 by 2 by 3. So this is one method. There is another method to solve this, and actually you should prefer this second method, okay, because this is faster and this is quite simple actually. In this case you don't have to take any substitution, you just simply put the value and you will get the answer directly, okay. So we have here x square minus x square dx. This we can write in this way. Sorry. Yes, this we can write in this way, yeah. because d of x square, what is d of x square? D of x square is 2x dx. D of x square is 2x dx. So I have taken a half outside. So this 2 and half will get cancelled out and we will get this one. Yes. Now we can write this in this way. Minus of half d of a square minus x square. Yes. Because d of a square minus x square, what we will get? Minus of dx square, and minus of dx square means we already have a minus here. Yeah. So this is minus of half, and we obtain a square minus x square d of a square minus x square. What is this? This is nothing. If we think in our mind that a square minus x square is t, so this is basically root t dt, right? And t to the power half, this is basically a square minus x square. Let me erase this, otherwise it will create. This is 3 by 2 times 3 by 2, and simplifying we obtain this as minus of 1/3 s square minus x square by 3 by 2. Yeah. You will have to use this formula. I mean, I would say that you better follow this process, okay? Because as long as you work on the integral in differential equation and in other, the more you will learn this, you will see that this approach is quite, this approach is very fast. This approach is very used to actually, okay? Okay, so we evaluate this integral, and what we are going to do now is, we will simply substitute the value here to obtain the area, okay? So you obtain the area of the first quadrant. Let's write it as A1 as 1 by A. This is basically minus of 1/3. I will simply substitute the value of this whole integral of this by this, yes, a square minus x square 3 by 2, yes, and our lower limit is 0 and upper limit is a. Yes, lower limit is 0, upper limit is a. So 1 by a, let's say it's 1 by 3a. I am pulling out this 3 outside, okay, and this is a square minus x square 3 by 2 0 to a. Any doubt? I simply change the limit, interchange the limit, and then remove the symbol, negative symbol. So this gives a cube, and then a is 0. So we have a cube by 3a. This is basically a square by 3. So we obtain the area of this orange region. Yes. See, initially we have been started working on this, only this part, only this orange part. Okay. So area of only this orange part, only this part is a square by 3. Therefore, what is the area of the whole curve? Since it is symmetric, as I mentioned earlier, the area of the whole curve is 4 times of this part. Okay. So the area of the whole curve is 4 square by 3. Okay. This is 3. Area of the whole curve is 4 square by 3. In this context, I just want to mention one more thing, that in the near future, whenever you will learn gamma function, beta function, you will also encounter this type of integral actually. Okay, and there you will find a formula for that. So we have to find the area of this parabola with respect to x-axis, right? So you can straightforward apply this formula, as we know that the formula of any curve like y dx, with this you can get the area, and then you have to evaluate the lower limit and the upper limit. But this is sometimes quite technical, right? If you if it is possible to draw the, if it is possible to get the graphical representation of this parabola, then how to do that? Okay. So first try that first. So you better pause this video. I would suggest you better pause this video and start drawing the parabola in the graph. Okay. How it looks. So what is the procedure? Let's say, forget about the area. Let's say you have given that to draw this parabola in a graph. Then how you are going to draw this? How it looks like? Let me use a different color. See, in order to draw a parabola, we need, how many points we need? We need at least 3 points, right? So, if we can get 3 points in the xy coordinate, in the Cartesian coordinate, then we can draw this parabola. So first thing first, what we are going to do here, we know the equation, we know the parabolic form, this is a parabola, we know the equation, and what we are going to do is, first we will investigate that at which point this parabola intersect the x-axis, both the positive and negative x-axis, and then we will try to investigate that at which point this parabola intersect y-axis. Okay, so this is pretty simple. In order to get those points at which points this parabola intersect x-axis, what you are going to do is, we will just substitute y equals 0, right? Because this is the equations of x-axis. Yeah. So if we substitute y equals 0, then from here we will obtain a square minus x square equals 0, which after simplification gives x equal plus minus a. So from here we can easily conclude that this parabola intersect x-axis, that is y equal to 0 line, at 2 points, a comma 0 and minus a comma 0. Okay, so we obtain 2 points, remain only 1 point. For that, what we are going to do is, yes, we are going to do at which point it intersects y-axis, that is, we will simply substitute x equals 0, and from here we will obtain ay equals 3a square, which is after simplification y equals 3a, right? Therefore it intersects y-axis at 0, 3a, y-axis or x equal to 0 line. So we obtain 3 points, and then from here we can now draw the parabola. Let's say this is Cartesian coordinate and the parabola will be like this. Let's say this is minus a comma 0, this is a comma 0, and let's say this is 0, 3a. Therefore the parabola will looks like this. Yeah, it will look like this roughly. So now that we have obtained the point at which parabola intersects the x-axis, then from here we can easily evaluate the area of this part, because see, this part and this part are symmetric, right? So as what we did in last few problems, that if we can compute the area, whenever we are encountering some symmetric kind of thing, then no need to evaluate the area as a whole. Just evaluate the area, in one part. Since another part is symmetric, so you just have to multiply how many symmetric parts are there. Like the last problem we did, the loop problem. We evaluate the area in the small part, and since we already know that the rest 3 parts are symmetric, so what we did, we just multiply by 4. In case of circle, what we do? We take the area of the first quadrant, part, then we multiply by 4, because there are four parts, four parts symmetric with that. I mean, look similar with that first quadrant type. Yes. Similarly, here also we'll do the same kind of thing. We know the first quadrant part and the second quadrant is definitely the symmetric. So what we are going to do is we will simply compute the area of this first part, and then we will multiply with 2, because there are two parts here. Yes, this is part 1, this is part 2. So what we are going to do is we simply compute the area of part 1 and then we will multiply with 2 by 2, multiply by 2, because these two are symmetric. Okay, so the area is, I am writing as a whole, total area is 2 times y dx. This is 2 times, we know y is 3 by a times s square minus x square, and the limit will be, this is, since we are only dealing with the first quadrant, so this is 0 0, so the limit will be from, lower limit is 0 and upper limit is a. Okay, so 0 a. Let me erase this line a bit here, otherwise it will be confusing. So this is the total area. Yes, 6 by a 0 a s square minus x square dx. Now this is pretty straightforward. Now just have to evaluate this integral 6 by a. I am not doing the integral part, I am substituting the value straightforward, but if you have any doubts you can ask me. So this will be s square x from 0 to a, and this is x cubed by 3 from 0 to a. It means a different symbol here. This is s square. So if we simplify this, this is basically 6 by a s square times a minus a cube by 3. A cube minus a cube by 3, this is 2a cube by 3, and we have a in the denominator, so 2a cube by 3 by 3a, so it will be 2s square. A will be cancelled out, one single a, so 2s square, 6 times 2s square by 3, this equals 12s square by 3. So the area of this parabola and the x-axis is 12 square by 3 square unit. You can write this square unit. Okay, in this case we have two parabola, y square equals 4ax and x square equals 4by. We have to evaluate the area between these two curves. So this is pretty straightforward. Drawing these two parabola, let me use different color. So we know that y square equals 4ax. It looks like this. Yes, and x square equals 4by. It looks like this. Yes, this is our x-axis, this is our y-axis, and this is our origin, and we have to evaluate the area between these two curves. Means this region, this orange region. You have to evaluate the area of this orange region. Okay, let's say this is A. Let's denote this point as A, and let us assume that the coordinate of A is alpha, beta. Okay, so what you have to do is, since you have to evaluate the area of this part, let's say OA, this orange region, we know the coordinate of O, we have to evaluate the coordinate of A, right, in order to evaluate the area of this region, because that will be our upper limit. Yes, we know the lower limit, but we need to know the upper limit. Only then we can evaluate the area, and we will obtain the upper limit only if we know the value of A, that is the coordinate of A. Yes, so how to get the coordinate of A? It is very easy. We know the curve when they will intersect, and what is the formula when two curves intersect to find the coordinate point of their meeting point? Yes, you simply substitute. Let's say since they meet at alpha beta, so from here we obtain beta square equals 4a alpha, and from here we obtain alpha square 4b beta at alpha beta, because these curves also pass through A, that is alpha beta, and these curves also pass through alpha beta. So this is the, this will be the relation. Let's do one thing. Let's not do the calculation, but let's keep this relationship as it is. Maybe it will be useful later. We have this equation 1 and we have this equation 2. Okay, do I need to write this clearly? Let's write it clearly so that you can understand. We know this 2. We have this relationship between alpha and beta in our hand. Okay, now what we are going to do is, we have to evaluate the area of this region. So let's say we have two curves given. Okay, y, let's say this is y equals fx, and let's say this is y equal gx. Now can you tell me what is the area of this part? Actually this is a very conceptual kind of problem. I would say that what is the area of this orange part? We know the upper curve is y equals fx and the lower curve is y equal to gx. Then what is the area? How to find the area of their between the region falling between these two curves? How to evaluate the area of this part? Do you know this? So this is a formula is something like this, that you just have to subtract the lower curve from the upper curve. This is the area actually, and then you have to take the lower limit and the upper limit, which is this point actually, where let's say this is x1 comma 0, and let's say this is x2 comma 0. Okay, so this is the formula actually. Okay, I am saying once again, upper curve fx minus lower curve gx. You just have to take the difference of these two curves. If you want, you can take mod, because area cannot be negative. Okay, but the concept is like this, that you just have to take the difference of upper curve and lower curve, and then you take the lower limit and upper limit, then integrate. So we will follow the same strategy here, the same formula here. So can you tell which one is the upper curve here? The upper curve is this green one, right? You don't have to look the whole, just look at this part. Just look only this part. Now forget about the rest of the part. In this part, the green is upper, right? And the blue one is lower. So what we are going to do is we will follow this formula. Upper curve, that is this green one, let's write as green minus blue. Yes, green minus blue. Now what is the equation for green one? It is y square equal 4ax, therefore it will be 4ax square root. Yes, minus what is the equation for blue one? This is x square 4b, so it will be x square by 4b. We don't know whether it will be negative or positive, but if you are unsure that whether it will be positive or negative, in that case you can take it as a modulus. Or at the end of the result, if you see that the result is coming negative, you can write this. Since area cannot be negative, so the answer is, let's say the answer is coming, let's say not for this one, let's say for some other problem. You are evaluating the area of a curve and you obtain -4. Okay, you can write there, you can mention there clearly that since area cannot be negative, so the area is 4. Now you can ask then what about the minus sign? The minus sign is coming because of the computation. Okay, because of maybe you are geometrically wrong. For that reason, negative symbol is appearing. It is not possible always to be geometrically correct while evaluating the area. Okay, or in order to remain in safe side, you can take mod. That is the best thing actually. But anyway, we will look after that thing further when we will obtain the result. But for the time being, we are not taking the modulus. Okay. Now we have to take the lower limit and upper limit. We know the lower limit is 0 and the upper limit is alpha, right? Yes. So this is the area of this orange part. 0 to alpha 2 root a root x dx minus 0 to alpha 1 by 4b x square dx. I am simplifying a bit more. Okay, so we obtain this. Now it is pretty straightforward. We have to simplify this integration. Better you do it, pause the video, you do it, solve it, and look back that what is the answer you are getting. Okay, alpha cube. Now from 1 and 2 we have to do we have to do some computation here using 1 and 2. Okay, what we know from 1 is, so what we have to do is we have to evaluate alpha from here. We have to evaluate alpha from here using 1 and 2. Our answer will be in A and B because we don't know alpha, we don't know beta. So we have to evaluate these two things. Those two are unknown. We have to convert them into A and B. Only then the answer, we will get the answer. And that is the correct answer. Beta square equals 4a alpha. So we have beta equals 2 root a alpha. So 2 root a alpha, this is, so 2 beta, this implies 4 root a alpha. Okay, so 4 root a alpha equals 2 beta. Yes. So from here we can write this as 1 by 3 root a alpha times 4. We can write this thing in this way, right? So we know we obtain 4 root a alpha is equal to 2 beta. So this is 2 alpha beta by 3. Yes, this is 2 alpha beta by 3, and this is from 1. Okay, and from 2 we have alpha square 4b beta from 2. If we multiply both sides with alpha, this is 4b alpha beta. So alpha cube is 4b alpha beta. Here we have alpha cube, this one. So 1 by 12b times 4b alpha beta. 4 will get cancelled out, b will get cancelled out. We have 1 by 3 alpha beta. Okay. Simplifying, this is basically 1/3 alpha beta. Now the whole problem, this whole expression boils down into this short expression 1 by 3 alpha beta. But still we are not, still we didn't get the answer. We are close to the answer, but this is not the answer. We have to convert it into A and B. So for that, what we are going to do is, we can multiply this 1 and 2. Okay, see, if we multiply this 1 and 2, in the left hand side you will get beta square alpha square, yes, and in the right hand side you will get alpha beta, and then 1 alpha beta will get cancelled out and we'll get the product alpha beta. Okay, so 1 times 2, this is beta square alpha square 4a alpha times 4b beta. This gives beta square alpha square equals 16ab alpha beta. Alpha beta will get cancelled out from both sides, so we obtain alpha beta equals 16ab. So yippee, we get the answer, right? So this is alpha beta equals to 16ab by 3. So the area, we have the known form now A and B, so we can safely say that this is our answer. Yes, so the area, this orange region, the area of this orange region is 16ab by 3 square unit. Yes, and observe that in this case our symbol is positive actually. So we are right, we are geometrically right, we are analytically right, and our answer, we have got our answer. So yes, we can enjoy now. Let's write it as square unit. So in this case, we have two parabola given, y square equal 12x and x square equal 12y. Okay, so it is pretty straightforward now after the earlier problem, because we did the same problem earlier, right? We know how to compute the area between two curves. Yes, we have this curve, we have this curve, and let's say this is O, this is A. We know the area of this part, that is A, is y1 minus y2 dx 0 to alpha, where let's denote it as A alpha. Okay, otherwise this A and this A will be in confusion. It will be a confusion. This A alpha denotes the area of this one. Okay, this A is for area. Okay, and this A is the point. So we compute this. We did this type of problem earlier, just before, right before we solve this problem, and we obtain the area of this type of region as 16 by 3 AB square unit. Yes. Now what is A and what is B here? I am not doing the same integration here because we already did this right before. But in the exam, you have to solve this as how we solved the earlier problem. Okay. So what is A and what is B here? If we compare this, y square equal 12x, the standard form, the standard form of a parabola is y square equal 4x, and in this case it is 12y it is given, and the standard form in this case is 4by. And from here we obtain 4a equals 12, that gives a equals 3, yes, and b is also 3. So this is basically 48 square unit. So we obtain the area of this region, of this, let's say this orange region, as 48 square unit. Now what we have to do here is, we have this line, there is a line here, let's say x equal, the line is given as x equals 3, okay. What we have to do here is, this x equals 3 is subdividing this region into two parts, right? We have to find the ratio of those area of the A. We have to find the ratio of the area of those two parts. Okay, let's say, now let me just erase this orange part now, or let's do one thing. I am drawing another curve. Let's draw a separate region here. Let's use different color so that you can understand. Let's use green color. Okay, so this is basically OA, right? And this is the line, let's say x equal 3. So what we have to do is, in this case, let's say this is yellow region, and let's say this is, let's take some different color, let's say this is pink region. So what we have to do is, we have to find the ratio. First we have to evaluate the area of this yellow region and this pink region separately, and then we have to evaluate the ratio of these two area. If we denote this as A1 and this as A2, then we have to evaluate the ratio of A1, A2 or A2 by A1, whatever is your choice. In this case, I am evaluating the area A1 by A2. Okay. So how we are going to do this? That is the question. How we are going to solve this? We know the total area, it is 48 square unit, but we do not know the separate part. We do not know what is A2, we do not know what is A1. But since we already know the total area, we know A, right? We know A alpha. We don't know A1 and A2. So if we can evaluate at least one of them, let's say we evaluate A2, then by subtracting from A alpha, we will get A1, yes? So we will do the same thing here. We will evaluate the area of either A1 or A2, and then we will subtract it from the original one. Okay? This is the method. So let's do it. But can you tell me one thing, that which part, evaluating which part of the area is beneficial in this case? Actually, evaluating the area of A2 is easier. Do you know why? Because we know the lower limit. If we evaluate the area, if we attempt to evaluate the area of A1, in that case we know the lower limit, but we don't know the upper limit. We don't know what is the coordinate of A. We don't know what is alpha, what is beta. We have to evaluate then alpha and beta separately. Did you get my point, what I am saying? If we evaluate the area of A2, we do not have to do any additional calculation. Okay, we know the lower limit 0, we know the upper limit 3. But if we attempt to evaluate the area of A1, then we have to know the upper limit. That is, we need to know the value of alpha, which is problematic. We have to do more calculation. We have to waste more time which is not required. Okay, so what we are going to do is we are going to evaluate the area of A2, and then we will subtract it from 48. You will get the area of A1. Okay, so A2 equals 0 to 3, since we know the upper limit 3, and same formula, y1 minus y2 dx, 0 to 3. What is our y1 here? Y1 is square root of this is our y1 and this is our y2. Okay, sorry, this is y2. So square root of 12x minus x square by 12 dx. Okay, we have to simplify this. This is square root of 12, 0 to 3, square root of x dx minus 1 by 12 x square dx, 0 to 3. Yeah, simplifying, x 3 by 2, 3 by 2, 0 to 3 minus 1 by 12, 0 to 3. Yes, so this is basically square root of 12, 2 by 3 times 3 root 3, because 3 to the power 3 by 2, which is 3 root 3, minus 1 by 3 times 12. In the numerator we have 3 cube. Now if we simplify this, see, this 3 will get cancelled out, right? So it will be square root of 12 times 2 root 3 minus this 3 will be minus 9 by 12. Simplifying 12, 2 root 3 means square root of 12. Yes, 2 root 3 square root of 12. So square root of 12, square root of 12, basically 12. Yeah, so this is 3 by 4. This gives us, for simplifying, 14 minus 3, 45 by 4. Yippee! We obtain the area A2. We obtain our A2 is 45 by 4. Okay, we know the total area 48. Therefore, what will be the ratio of A1 by A2? So what is our A1? A1 is 48 minus 45 by 4, and we know our A2 as 45 by 4. So this gives 48 times 4, 4. So this 4 will be cancelled out. This is 48 times 4 minus 45. Simplifying, we obtain, what we will obtain? Now observe that I think we can simplify this a bit more, because we can take 3 common from the numerator, right? So we obtain 16 times 4 minus 4 minus 15, because we take 3 common, 15, and this is basically 64 minus 15. 64 minus 15 is 49 by 15. So the ratio, this A1 times A2 is 49 by 15. So what is the ratio of this two, of the area of this two region is 49 by 15. Okay, if you have any doubts in this problem, let me know. So we have in this case one parabola, and the line is y equals mx. What we have to do is we have to find the area between the parabola and this line. Let me use some different color first to draw the Cartesian coordinates. This is our parabola. Let's say this is the line, this is origin, this is, let's say, A. Okay, so we have to evaluate the area of OA. That is, we have to evaluate the area of this orange part. Okay, so it looks something like this. Okay, this one. We have to evaluate the area of this part. This is O, this is A. So the same formula. Which one is the upper curve here? This one, right? Let me use black. A alpha equals 0 to alpha y1 minus y2 dx. y1 is the upper one and y2 is the lower one. 0 to alpha, we don't know what is alpha, but we will evaluate this after some time. Okay, as what we did in that problem. So this is y1 is, here we have square root of 4ax minus y2 we have mx, okay, dx, square root of 4a 0 to alpha dx minus m 0 to alpha x, and this gives 2 root a. This is again x 3 by 2 0 to alpha minus m x square by 2 0 to alpha alpha 3 by 2 by 2 alpha square. Okay, and this is basically 4 by 3 after simplification minus m by 2 alpha square. Now we don't know alpha, we have to evaluate alpha. We have to get the answer in the form of a and m, okay, because these two values are given, a and m. The same method as we did, since alpha beta is the intersection, intersecting point, so beta square, let me use some different color, beta square equals 4a alpha and beta equals m alpha. Okay, so if we subdivide this, so if we divide this, we obtain beta equals 4a by m, right? Alpha will get cancelled out, one beta will be cancelled out, so from here we obtain the value of beta as 4a by m. So we know the value of beta. Now if we substitute the value here, let me write it. Now substituting the value of beta here, 4a by m equals m times alpha implies alpha equals 4a by m square. We just have to substitute the value here and simplify it. That's all. Pretty straightforward. We just have to do some calculation. 4a by m square 3 by 2 minus m by 2 4a by m square whole square. Now if we simplify this, 4 by 3 4a 3 by 2 m cube, right? Because this 2 and 2 will be cancelled out. M by 2 16 square by m4. Simplify this. 4 by 3 square root of a. This is basically 4. 4 divided 3 by 2. Minus 8 divided 3 by 2 by m cube minus 16 square by 2m cube. This gives, now we have 4 by 3 a square times 4 to the power 3 by 2. It means 2 cube, right? And from here we have 16 by 2 means 8. Yes. So this is basically 8 square by m cube. We also have one m cube here, this one. So this is basically 32 square by 3 m cube minus 8 square by m cube. Yes, this is 3. So 32 by 3 s square by m cube. S square, we can take s square by m cube common. Yes. Let's continue it here. So s square by m cube taking common, we obtain 32 minus 32 by 3 minus 8. This 24. 32 minus 24 is 8. So this is basically 8 by 3 s square by m cube square unit. Yeah, this is pretty straightforward simplification. That's all. There is nothing big deal here. Okay. So we observe that in the last few problems, the main formula, what is the take on lesson from here is, the main thing is this formula actually. The difference between the upper curve, the lower curve, and then we have to take the limit, and then we have to determine the limit. Once we determine the limit, we have to take the difference of those two curves, and then we will get the area bounded by the curve. Yes, area bounded by the curve. In order to get the area bounded by the curves, we just have to take the difference of the upper curve and lower curve, and then set the limit, lower limit, upper limit, and then we will get the area. Rest are all calculations, right? These are all some complex calculations, but the formula is just this one. This is the main thing actually. Yeah, this is the main thing. Okay, so if you have any doubts in the problem that we have solved till now, let me know in the comment section. Yes. Okay, see you.